Hello, this is topic 10-3 on exploring data. And so first off, let's go ahead and we have a table, we have a graph. Let's make a scatter plot. And I've already taken the time to write this out, this being the year, and this being life expectancy. Okay, so you may want to pause it so you can fill in all your numbers. This right here just means that it's a jump. Instead of going from 0 to 85, which would give me a graph that's hard to do, I just jumped up to 40 and then counted by 5s until I got to 85. So the year 1900 had life expectancy of just over 47 years. So we're looking at a dot that's about right there. In 1910, life expectancy was exactly 50 years. Aren't you glad you didn't live back here? In 1920, it was 54.1. That's almost 55. In 1930, it was getting close to 60. 1940, it was almost 63. In 1950, it was just over 68. In 1960, it was almost 70. In 1980, it was just over 70. In 1970, it was just over 70. In 1980, we went up to almost 74. And then in 1990, we were just barely over 75. And so if you look at this, it goes up and it's kind of a curve up, and then we hit a little slow part and we would start to curve up again. Now, this is obviously not a straight line. So, if we were to create a line based on this, it would be the line of best fit. Alright? Now, we can actually use our calculator to get an accurate line of best fit. Whereas before in 10-2, we were just kind of guessing and estimating where that line was. Today we're going to use the calculator to find out what it is exactly. Okay? This is called a linear regression. Alright? Now, to do this, we're going to follow the instructions here. We'll go to Stat, Edit, and then we should see a bunch of columns. So my calculator, I find the Stat button that's right here underneath Delete. The very first option is Edit, and you'll notice that there's L1, L2, L3, and it'll keep on going. And I already have a bunch of data typed in here. In fact, I have already put in the numbers over here and the numbers over here. This goes in L1, and that goes in L2. And if you keep reading the directions basically tell you to go ahead and put everything into L1, then put everything into L2, and you can follow these directions for how to get it. But mostly you want to put the X's in L1 and the Y's in L2. Now step number 7 is something that you only have to do once. Okay? So I'm going to second quit so I can get back to the main screen. And now if I follow instruction number 7, it says that I need to push the second button and then go all the way down to 0. Notice how it says catalog. And I get a long list of everything this calculator can do, and I want to find diagnostic on. Well, that would be a long way to scroll considering all of these are A's. So a little shortcut is you see the green letter D? You can hit that button and it jumps you down to D, and then we just kind of scroll down to diagnostic on. And then I'll hit enter, and I'll hit enter again until it says done. Okay? Notice I had to enter twice. This step only has to be done once. Okay? Now, I'm going to go ahead and go back to Stat. Then instead of Edit, I want to go over to Calculate. And it gives me a list of different functions I can do. And I want number 4, which is my linear regression. Now I can type 4 or I can scroll down to 4, but this is what I want. And I hit enter, enter, and it gives me all of these numbers down here. Okay? Now I want to point something out. I know that we say that M is slope, but on this, they call A the slope, and B is still the y-intercept. A is slope, and B is your y-intercept. Now, using this information that we have on our calculator screen, we're going to answer. First off, I want the line of the best fit, round to the nearest thousandth. So y equals 0.10ths, hundredths, thousandths. Well, that 8 rounds that 5 up to a 6. X minus 570.35. Look at that 6. That 3 keeps it down. And this is my equation. Let's go ahead and turn the page. So using that equation, we want to know what was our slope. Well, our slope was 0.326. And our y-intercept, that was a negative 570.536. And here's the tricky part. What does it mean? Okay? So the y-intercept is where x equals 0. Okay? So x was year of birth. So basically this means that life expectancy would be negative 570.5 at year 0, which obviously does not make any sense. Okay? We obviously can't have a negative life expectancy, but you know, that's what it would mean. All right? It doesn't have to make sense. You just have to know what it means. All right? Making sense would be great, but realistically, what started happening is at the 19th century, we started making significant advances in medicine, which allowed us to increase life expectancy at a linear rate, at a nearly linear rate. Okay? Basically, every 3 years was an improvement of 1 year on life expectancy. Now, Here, we want to know, what's the life expectancy of a person born in 1942? Well, this is our year. This is our x. So, my equation of y equals 0.326x minus 570.536. I'm going to replace that x. So y equals 0.326 times 1942 minus 570.536. And what do I get? Well, I'm going to put that directly into my calculator. 0.326, 1942 minus 570.536. And I get that this is approximately 62.6. Okay? What about 1986? I'll do the same thing, but instead of 1942, I'll put 1986. So, y equals 0.326 times 1986 minus 570.536. And that's going to be approximately 76.9. And in the year 2000, y equals 0.326 times 2000 minus 570.536. And that's approximately, if I put it directly into my calculator, 81.5. Okay. Well, this person is born, I guess they had amnesia. They remembered that their life expectancy was 67 years. And we want to figure out what year they were born. Well, that means that y equals 67. So I go back to my equation and I'll replace the y with 67. So 67 equals 0.326x minus 570.536. And I solve it. Start by adding the 570. And that gives me 637.536 equals 0.326x. Divide by 0.326. And I get that x is approximately 1955.6. So that would have been 1955. Actually, it's a little bit closer to 1956. And so that is probably the year he was born, was 1956. 1955 maybe, but his life expectancy was 67 years. Now let's take a look at our next example. Now here, the table below shows the hours of TV watched by 10 students and their scores on a math quiz. Well, the independent variable, that's the one the students controlled. They controlled how many hours they watched TV. Hours watching TV. And the dependent variable would be their math quiz score. And so now we want our equation line of best fit. So these will go into L1, these will go into L2. So stat, edit, and notice I've got all my years here If I wanted to get rid of them, I could come up here and I would hit clear, hit enter. Or I can come over here and I can just delete the individual numbers. I do not want to delete L1 or L2. And clearing down here really doesn't do me much good. And so I would start typing these numbers into L1 and these numbers into L2. But I've already done that on a different calculator, just to save us a little bit of time. So now I go to second quit, I go to stat, calculate my linear regression, and I get that y equals a negative 1.355x plus 87.157. So my slope is negative 1.355, and my y-intercept is an 87.157. Now notice, I did not have my R values. So I set my diagnostics on the other calculator. I did not do it here. So I need to do that again, just as a refresher. Hit second, catalog, and then go over to diagnostic on. And that is done. And then stat, calculate 4, and now I have R values. Now, earlier, you may have noticed that my R value was a 0.9. And over here, my R value is a 0.3. What that means is that for the life expectancies in the years from 1900 on, there was a high correlation value. That means that that line predicted it extremely well. Because I have such a low value here, what that means is that this line is a poor predictor. Okay? It is a very poor predictor. Okay? But we're going to go ahead and do this anyway. What would our y-intercept mean? What our y-intercept means that a student who, and remember we want to know when x, what the x value is, and obviously my handwriting is getting worse, that a student who, and they had control over how many hours they watched TV, watched no TV, should make an 87. A student who watched no TV should make an 87, based off of our quiz. Now, obviously people made higher than 87 who watched some TV, and so just goes to show that this is a poor prediction. But they're asking us these questions anyway, so we're going to go ahead and do them. If someone watches 20 hours, we'll know what it would be. Well, 20 is our x, so we plug this in. Y equals negative 1.355x plus 87.157. And that's approximately a 60. So if they watch 20 hours of TV that week, I think it's for a week, doesn't even say. but the numbers are pretty big. So if they watched 20 hours, they should have made a 60. Over here, if they made a 70, we want to guess how many hours they watched. So that 70 equals our y value. So 70 equals negative 1.355x plus 87.157. We subtract the 87.157. And we get a negative 17.157 equals a negative 1.355x. We divide that. And we get 12 is approximately, actually it's 12.6, so we'll call that about 13 hours. Now again, these are poor predictions because of our poor R value. Whereas with life expectancy, we had a high R value, almost 1, and so that would be a very accurate prediction. Good luck on your assignment and have a good day.